All right, guys, this is the 2016 BC exam, question number 6. This is the Taylor question. And you're given f of 1 equals 1, f prime of 1 equals negative 1/2, and then you're given this formula to figure out what other derivatives are. The first question asks you to write the first 4 non-zero terms in the general term. So to do that, you need a couple other derivatives. So there's the second and third derivative evaluated at 1, and I'm just plugging a 2 in where I see n, and a 3 in where I see n, and evaluating. So there's those guys. You should know the Taylor form, or you got your formula sheet, you can look at it. That's just plugging and chugging and then cleaning up, okay? The general term, so when I did this general term, I just kind of looked at it and I thought about, well, like that's like the 0th term, the first term, the second term, the third term, etc. And I'm thinking about that, like the reason I know that's the first term, kind of that's like to the first power, to the second power, to the third power, like so. It's obviously alternating. It's obviously x minus 1 to the n. And then I just kind of thought about the denominator for a minute and was able to relatively quickly figure out that it was n times 2 to the n. Part B, it says the Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence and then show the work that leads to your answer. Okay? So we know it's centered about x equals 1. So like if the radius is 2, that means that instead of this being a negative 1, the gut's positive 1. Well, now the radius is 2, so it's negative 2, the gut's positive 2. Some pretty simple algebra puts me to here. And that's my preliminary answer because I got to think about, is it a p-series, okay? So before I get into that a little bit, under the general term, I kind of like rewrote it a little bit, like he's here, this guy's here, and then I split this fraction up into 2 pieces just to kind of really illustrate that this can be a p-series if it's not alternating, okay? So I got to consider that. Now, I'm plugging my endpoints of my interval in right here to see if it alternates or not. If I plug a negative 1 in, and I'm plugging it in up here, this is just an easy place to see it. If I plug a negative 1 in, positive, he'll turn positive, he squares to positive, he'll turn positive. So with negative 1, it doesn't alternate, which means that it is a p-series, so it won't converge. No or equal to sign. If I plug a 3 in, he's positive, he'll be negative, right? Negative 1/2 times a positive is negative. He'll be positive, he'll be negative, and etc. So it does alternate, which means you don't have a p-series, or it's like an alternating harmonic, which does converge. So he gets the equal to sign. Part C, it says the Taylor series about for f about x equals 1 can be used to represent f of 1.2. As an alternating series, use the first 3 non-zero terms to approximate f of 1.2. Well, that's really easy. All right, so 1, 2, 3 terms, and where I see x, I'm putting 1.2, okay? And then I'm just kind of cleaning it up, right? 0.2 is 1/5 in fraction terms. Just easier to think about it that way, in my opinion. So there's me plugging it in and getting 181/200. So that was really easy, probably only worth 1 point. And then part D says, show that the approximation found in part C is within 0.001 of the exact value. This is alternating. So you can just figure out what the absolute value of the first term left off is and see if your approximation is within those bounds. That's your Lagrange error bound. So the first term left off was the cubed. That guy right there. So again, it's just the absolute value of that, so I don't really care about the negative sign. All right, so there's me plugging in, and I'm getting out 1/3000. If you think about it, 0.001 is 1/1000, and 1/3000 is certainly less than 1/1000. So there's your proof. All right.